This video is going to talk about how to save money and the formulas that we use to calculate. Interest is not always a bad thing. It can lend a helping hand when we're saving money. Whether it's for a particular short-term goal or long-term retirement plan, we can use interest to our benefit. Present value is the amount of principal needed now in order to reach a future value amount. The present value is calculated with this formula. A, that's the future value that you're trying to get, over 1 plus R over N to the NT. And you already know R is the rate and N is the compound intervals per year, T is time. State College predicts that in 18 years it will take $150,000 to attend the college for 4 years. Amber has a substantial amount of cash and wishes to save money for her newborn child's college fund. How much should Amber put aside in an account with an APR of 4% compounded monthly in order to have $150,000 in the account in 18 years? Okay, so we're going to use our present value formula. She's trying to get $150,000. The rate is 4.4%, so 0.04. It's compounded monthly, so N is 12. And we're doing it for 18 years. Simplify a little bit, especially if you're not using a graphing calculator or Excel. 0.04 divided by 12 and then add 1 using as many decimal places as possible. And 12 times 18 is 216. So you would first start with your exponent, so raised to the 216th power, and then you want to divide 150,000 by that number. So again, if you're using a regular calculator, you're going to want to write down all the decimal places and then 150,000 divided by that number here. Whatever it is, okay? And you should get about $73,100.31. So as long as she has a little over $73,000 right now, she'll be able to save enough for her daughter to go to college in 18 years. Or son, it didn't specify, did it? An annuity is a sequence of regular payments made into an account or taken out of an account over time. The annuity formula is the future value equals the PNT, that's your payment, whatever payment you're making per month, times, big long stuff, 1 plus R over N to the NT minus 1 divided by R over N. Daigle begins placing $75 per month into an annuity savings plan when he begins receiving his first official paycheck in August of 2014. The saving plan earns 2.5% APR, compounded monthly. Determine the amount of money that Daigle will personally put into the savings account over 10 years. Okay. So far, we're not figuring out the future value. We're just saying how much will he put in, not including the interest, okay? That would be the payment amount of $75 times the payments per year. That'll be 12 times the number of years. 10. Okay? So he will be investing $9,000 over those 10 years. Now let's see how much he'd end up with over time. Okay, so the future value is the payment times 1 plus R over N to the NT minus 1 over R over N. So his payment is $75. The rate was 2.5%, so 0.025. 12 times a year for 10 years. And we put the same R over N on the bottom. Okay, so we'll go over how to put this in Excel. Lots of parentheses. But if you don't use Excel or a graphing calculator, then as many decimals as possible. 1 plus 0.025 divided by 12 would be 1.002083333. 12 times 10 is 120. And just 0.25 divided by 12 is 0.002083333. So if you raise to the 120th power and subtract 1, and then divide by this number on the bottom, you'll get 136.171962. And that comes to $10,212.90. That's how much he'll have saved after 10 years. So he's gained quite a bit in interest there. Example 3 says, use the annuity formula to calculate the future value after 6 months of monthly $50 payments for an annuity savings plan having an APR of 12%. So the future value would be 50 times 1 plus your rate, 0.12 divided by 12 to the N times time. And since it's 6 months, then we're just looking at half a year. Then minus 1 divided by 0.12 divided by 12. $307.60. Again, check yourself. Shoot me an email if you don't get that answer. At the age of 25, Angela starts an IRA, that's a retirement account, to save for retirement. She deposits $200 into the account each month. Based on past performance of similar accounts, she expects to obtain an annual interest rate of 8%. Well, let me tell you something. From what I've looked, I've not seen one with an interest rate that high, but okay, we'll go with that. How much money will Angela have saved upon retirement at age 65? Okay, so she's 25 now. So T will be 40. We just subtract. And we'll plug into that same formula. The payment is $200 times 1 plus our rate, 0.08 divided by 12, to the 12 times 40, divided by 0.08 over 12. Okay? Okay. I'm going to work this one out. So if we do 1 plus 0.08 divided by 12, you get 1.00666. How many 667. 12 times 40 is 480 minus 1, And on the bottom, we'll have 0.006666667. On the top, if you raise to the 140th power and subtract 1, you get 23.27338554. And again, I'm going to show you how to put this in Excel. And then you could just save your formula. And whenever you have a problem, go plug in the numbers. You got your answer. Real simple. So she'll have $698,201.57 after 40 years. Compare the future value to the total amount Angela deposited over time. So over time, over 40 years, times 12 deposits per year, and $200 at each deposit was $96,000. So if we subtract that, from the amount that we found in the previous example, or part A, then she has gained $6,201.57. That is awesome. The annuity formula for finding payments amounts. So what if you are wanting to get a certain amount in the future and you want to see how much you need to invest each month? Then you're going to use this formula. Suppose you'd like to save enough money to pay cash for your next computer. The goal is to save an extra $3,000 over the next 3 years. What amount of monthly payments must you make into an account that earns 1.25% interest in order to reach your goal? So your payment would be the future value times R over N divided by 1 plus R over N to the NT minus 1. Notice these formulas are just all manipulations of the same thing. If you solve for something different, you're just, going through how to solve an equation for something different with all the same numbers. So our future value needs to be $3,000. The rate is 0.0125 divided by 12 times a year. And on the bottom, 1 plus 0.0125 divided by 12 to the 12 times 3 years minus 1. So working this out, 0.0125 divided by 12 is 0.001041667. Add that to 1 for the bottom. You got 1.001041667 to the 36 minus 1. Raise to the 36th power and subtract 1, and we have 0.03819173338. So she needs to deposit approximately $81.82 each month. $82. Oh, I'm looking out my window again, and there's the mama deer with her 2 twins, still with spots. Oh my gosh. I'm sorry. I need to shut my curtain. Okay, example 6. Oh, I'll have to get a picture of them sometime to send you. Okay, Amber wishes to deposit a fixed monthly amount into an annuity account for her child's college fund. She wishes to accumulate a future value of $150,000 in 18 years. So we're going to use this same formula with an interest rate of 4%. So the future value needs to be $150,000. Rate divided by n over 1 plus the rate divided by n to the n times 18 years minus 1. I'm not going to work this one out because I did the previous one. She needs to deposit a little over $475 a month. Part B asks, how much of that $150,000 will Amber ultimately deposit into the account herself, and how much interest is earned? So she's going to deposit for 18 years, 12 payments a month, of $475.30. She's depositing $102,664.80. So how much was that of interest? She's gained $150,000. So we'll subtract off this amount that she's deposited. And in interest, she has gained $47,335.20. In example 7, assume you have just graduated from college and have obtained your first job making $44,000 or $44,250 per year. Currently, the national average retirement income for people with a bachelor's degree is $60,000 per year. So, in other words, you're wanting to retire and get $60,000 every year after you retire. Assuming you are 22 years old at graduation and you'll retire at 67, then you'll be working and investing for 45 years. At current rates, a mutual fund has an APR of 8%. How much do you need to invest each month in order to live off $60,000 per year when you retire? So you're going to have to ask yourself several questions here. How much do you need to retire? Write down. When I write this down, you write it down. Because when you're looking back at these problems, you want to make sure in your notes that you understand why we did what we did. Excuse me. So how much do you need to retire? Well, you need to ask yourself, how much do you need to get $60,000 a year every year in just in interest when you retire. So you want to accumulate enough money over these 45 years so that every year just in interest you've got $60,000. Not that you're subtracting from the amount that you've accumulated at all. You're just getting it in interest. Okay, so to find that, we need to figure out 8% of what would get you $60,000. So divide by 0.08. You need to have $750,000 in your retirement account when you retire. So the payment would be how much you're needing, $750,000 times your interest rate of 0.08 divided by 12 times a year divided by 1 plus, I always do that, 1 plus 0.08 divided by 12 to the 12 times 45 years minus 1. Okay? And so you'll put that in your calculator or Excel and get $142.19 is all she needs to invest each month in order to retire with $60,000 a year. Excel. So in the first problem, we had an amount that we were trying to accumulate of $150,000. The rate was 4%. N is 12. T is 18. So to put this into our formula, we have equals our amount divided by. We need to put a parenthesis around everything on the bottom. So we have 1 plus, parentheses are around R over N, so R divided by N, close, and then close everything on the bottom there, and then to the NT, so N times T. And there is our answer. We have a payment of $50, a rate of 12%, N is 12, and T is half a year. So we got equals, and our payment, select there, times. Then we've got a lot of parentheses here. We need a parentheses around everything we're getting ready to do. We need a parentheses around the top, and we need a parentheses around the 1 plus R over N. So 1 plus, we need parentheses around R over N. Then we'll close the parentheses for the 1 plus R over N. We're raising that to N times T. Close. Then minus 1 and a parentheses around everything on the top, divided by parentheses around the bottom, R divided by N, and parentheses around everything that we're multiplying times 50. 3. So we were trying to find how much the payment would be if we want a future value of $3,000 at a rate of 1.25%, compounded, or 12 times a year, your payment, and over 3 years. So equals your future value times, we need a parentheses around everything we're getting ready to do that we're multiplying by the future value. Then we need a parentheses around the top, R divided by N. Then we're dividing, and we need a parentheses around everything on the bottom, and a parentheses around our 1 plus R divided by N. So 1 plus parentheses over R divided by N, so many parentheses. And then a parentheses over 1 plus R divided by N that we're raising to the NT, which will be in parentheses. Minus 1, close everything on the bottom, close everything times our future value, and cross our fingers, we got it.